assessment asks us to predict a product for this reaction. Sodium methoxide will form an enolate at carbon number 2 that will be a nucleophile and will attack the electrophile at carbon number 7 of the epoxide, opening up the epoxide, forming an alkoxide intermediate at carbon 8, which will get protonated in a proton quench, acid quench, to form an alcohol. So our product then will have our cyclopentane ring still intact. That's carbons 2 through 6. Carbon number 1 will still be attached. It will be a new stereocenter now. And then we will have carbon number 7 and 8, where 8 still has the oxygen of the epoxide attached and it gets turned into an alcohol. And then carbon 9 with the OBN group. So this is the structural formula for our product of this reaction. The stereocenter at carbon number 8 is set from our electrophile, so that doesn't change. But we get a new stereocenter at carbon number 2, and that is variable. So we get this product plus its diastereomer. The version where this ester group is also on a dash. The stereocenter at carbon 8, though, does not change. It was set in our reagents. So these two diastereomers are the product of this enolate alkylation reaction.